Okay, so the first two examples here, it says example 1A and 1B. We just got to find the mean, median, and mode for each data set. Let me use my book too here. So the first data set, we have 6, 9, 3, and 8. Well, in order to find the one in the middle, you got to put them in order, right? So you got to put them in order left to right. So let's do that over here on the side. So we've got, I got plenty of room over there. So we had 3, 6, 8, 9. So again, I haven't done this in a while, so. So 3, 6, 8, 9. So then how do we find the mean? How do we find the average? Yeah.
You add them and then divide them by the number one.
Yeah, you add them up and then you divide by 4 because you got 4 values, right?
Yeah.
So I'll go ahead and write this out on this one. So it's the mean. So we're just going to do 3 plus 6 plus 8 plus 9 all over 4 because we have 4 data values. And then if you want to put it all in the calculator at once, you probably want to put it in like that with some parentheses around the numerator. And then the symbol for the mean that we're going to use, it's an X with a bar over the top of it. So when you see that symbol, we know that means the mean. So let's see. So if we add those up, we would get what? 3 plus 6, that's 9. So we got 9 and 9 is 18. 18 and 8 is 26. So we end up with 26 over 4. So let's see, half of that would be 13. So half of that would be 6.5. So 6.5, that's our mean. All right, and then the mode would be the one in the middle. Well, this doesn't really, there's an even number of data values here, so there really isn't a data value in the middle. So what you have to do is you have to average these two. So when there is no middle value, when the data set contains an even number of values, then find the average of the two in the middle. So then to average those, you just add them together and divide by 2. Now this one you could probably see in your head, the number that's halfway between 6 and 8 is going to be 7, right? But just so you know, I'll write it down here. So you would take the 2 in the middle, add them together, divide by 2. Like that. So that's going to give you 14 divided by 2, that's 7, right? So that's equal to 7. So that would go right in the middle here. Oh, wait a minute. So right in the middle there. So it's 7. That is our middle value, so that's our median. And then the other one we got to do is the mode. Well, the mode is the one that... The mode is the one that occurs most often, but these all occur just once, right? So there really is no mode on this one. So the mode on this one, we'll just put none. Okay, so the mode, there isn't one. The average or the mean is 6.5. The median is 7. All right? Pretty easy so far, right? So none of this stuff, again, some of it gets kind of tedious, but the math in this section or in this chapter is not that difficult, all right? Just a lot of arithmetic, really. So let's look at the other data set here, this one. So this one over here, this one's got 2, 5, 6, 2, 6. So I'll write that down for you guys. So this one has 2, 5, 6, 2, 6. All right, so we need to do the mean again, so we'll do the average. So we're going to add them up. I think we just do that real quick. So we got 2 and 5 is 7, plus 6 is 13, plus 2 is 15, plus 6 is 21. So we got 21 over, we got 5 values, right? So that's going to give us, I don't know, what is that, 4.2? So that's our mean. Then to do the median, we got to put them in order. So that would be 2, 2, 5, 6, 6. So this time, if we put them in order, we can see we've got an odd number of data values. So if we have an odd number of data values, then we can find one in the middle, right? If we kind of count in from the outside. So you got these two, you end up with this one in the middle. So 5 is going to be the median. So right there. So the median, is 5. And then the last one, what's the mode on this one? Which one occurs most often? Yeah, 2 and 6, right? They both occur more than one. So you can have more than one mode. It's a tie. They both occur twice. So then the mode on this one, you got 2 as a mode and also 6. So 2 and 6. So that's it for the first part. Let's go to the next part. So the next one we want to look at is, what do we want to look at here? Let's look at example 3 on page 830. So I'm looking at this one up here. Okay. So what we have to do in this one is it says we want to make a box and whisker plot, and we want to find the inner quartile range. So here's your data set right here. And I think maybe we'll kind of use what they did here to help us out a little bit, maybe. Let's see, can I do that or no? I don't know. Well, we're going to put them in order, right? So if you look there, we need the median. We're going to need the middle value, so we do definitely have to put them in order. So maybe I can, let's see. If I can see my book over here. It's pretty dark. I think I can put them in order. So let's go over here and put them in order. So we've got, if I put them in order, we have got a 2, a 2. We've got 2 3s. We've got a 4. We've got 2 5s. We've got a 6 and a 7. We've got 3 8s. We've got 2 9s. We've got a 12, a 13, a 14, and a 15. I think that's all of them. Let me make sure. So what you would normally do is, what I normally would have done, you guys, is I would have been like going, as I put them in order, I would have been crossing them out. You know, I was saying, okay, there's a 2 there and a 2 there, so there's 2 2s. Then there's a 3 there, a 3 there, so there's 2 3s. So I would have been crossing them out as I went along, but I couldn't see that part of the page at the same time. So let me just count them. So I got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So there should be 18 of them altogether. So hopefully I got 18 there. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. Yeah, I got them all. Okay. So there's 18 of them. And then you kind of want to work your way, into the middle, right? So let's see, where would the middle be? The middle would be, I think these two would be in the middle, right? If you check, let's see, I'm gonna erase this in a second. You'd have how many over here? You got 1, 2, 3, 4, 5, 6, 7, 8. And then over here, you've also got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I got it right. So the middle is going to be right in the middle between 7 and 8. So what would that be? The middle right here. What's halfway between 7 and 8?
7.5.
Yeah, 7.5. If you average those again, like I did on the other one, you would do 8 plus 7 divided by 2, which is 15 divided by 2, and you get 7.5. Okay? So you guys should be able to see that right here. This is your median. So your median is 7.5. All right? So now, exclude your median take your median out of the data, okay? So do not include the median. And then let's look at the lower half of the data. So the lower half of the data is going to be all of this stuff. All right? So then, what's the middle of the lower half of that data? What number's in the middle?
3 and 4.
Actually, the 4 is. Yeah, it's the 4. See it right there? Because then you got 4 data values here, and you got 4 data values here. So again, do not include the median though. So if you happen to have an odd number of data values, do not include the median when you look at the lower half of the data. All right, so the 4 is in the middle of the lower half of the data. So they gave this thing, they call this this is called the first quartile. So that is the first quartile. Let me look at this thing real quick. Yep. All right. Then we do the same thing with the upper half of the data. So again, don't include the median. And then you got this upper half of the data here. So what's in the middle? What one's in the middle of that upper half? The 9. Yeah, this one right here, right? That 9 right there. Because then you got 4 data values here to the left of it, and you got 4 data values to the right of it. So it's that second 9 that I have there. Well, that's called the third quartile. So that one, that 9 right there, that's called the third quartile. Okay. And then a couple other data points you want to make note of on this then is you want your first one, that's called your minimum. So minimum, I can't write, hold on. I'm too close to the edge of the page. There. Minimum. And then this one over here, your largest data value, that's called your maximum. I still can't read minimum over here. I'll try one more time. That's supposed to say minimum. That's a little better. Okay, so to make this box and whisker plot, that is the 5 values that I need. I need the minimum. I need the first quartile, which your book will call Q1. And then I need the median, the one in the middle, the 7.5. I also need the third quartile, which your book will call Q3, or Q subscript 3. And I need the maximum. So those are the 5 values I need. So let's see if I can draw this thing for you guys. So you need to make a number line. So make a number line like this. And then you actually do need to scale it equally. So we need to go all the way from 2 to 15, okay? So we're going to go, here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 right there. And then the 5 values that we want to mark on that number line, well, we need the minimum, which is 2. We need the first quartile, which would be 4. So 2, 3, 4 would be right here. Then we need the median, which would be 7.5. So let me find that. Where's that at? That's 2, 3, 4, 5, 6, 7, 8. So here, I'll put 7 and 8 on there so we can see. So that's 4, 5, 6. So there's 7 right there. There's 8 right there. So we need the 7.5, which is the median. So put that in the middle there. And then we need the third quartile, which was 9. So that would be here. And then we need the maximum value, which is 15, which is here. And then, I guess I could label a couple more of these. So let's see, the first quartile, that was 4, right? And the third quartile was the 9. So then what you do is on the, at the first quartile and the third quartile, you make a little rectangle like this. And then you draw a vertical bar in there at your median in the middle right there at 7.5. I guess I could label that. And then you draw a whisker out to your maximum, like that. And then you draw another whisker out to your minimum like that. So you got a box, which is that rectangle, and then you got 2 whiskers. Now, what does that do for you? That's kind of a picture for like how spread out your data is. So what you have is you have 1/4 of your data falls in this interval from 2 to 4. And then another quarter of your data, or 25% of your data, is between your first quartile and your median. And then another 1/4 of your data is between your median and your third quartile. And then the highest 25% of your data is in this interval from the third quartile to the maximum. Okay? And then a couple other questions they would ask you about this stuff. Let me slide up here. I think I can do this from here. Is they'll ask you for what is the range of your data. So your range is just your maximum minus your minimum. So in this case, that's just going to be 15 minus 2. So that's 13. That's the range of your data. That's how far apart your min and max are. All right, and then the other one they ask you for in your book is they ask for the interquartile range. So that is the, let me write this thing out. So interquartile range. So that is your third quartile minus your first quartile. So in this case, that is going to be, let's see, what do we got? Our third quartile is at 9. That's the right side of that box. And then the first quartile was at 4. That was the left edge of that box. So you get 9 minus 4, so that's equal to 5. Excuse me. So that's how spread apart your first quartile and your third quartile are. All right, so that's about it for the box and whisker stuff. I'm actually going to go back now. I'm going to pick up example 2 real quick. This one will go a lot quicker. Again, none of this stuff is that tough. The math is not that tough, but there's quite a few concepts and it can be kind of tedious. But there's no weird algebra or functions or any of that kind of stuff going on here. So let's go back and look at example 2. So if we go back to look at example 2, I got to go back a page here. So example 2. So what we got here is it says, we've got this data here for World Series games. And what this is called expected value. So what they're telling you here is, let's see, what is this? This is the number of games, like the World Series, right? You got to win, whoever wins 4 out of 7 games first wins the series, right? So they're saying that, let's see, if you look from 1923 to 2004, I believe that was like 81 years. What they did is they reduced these fractions, okay? So right here they got 5 out of 27. Well, if you triple both of those, it was 81 years between 1923 and, what did it say again? I lost it. Between 1923 and 2004. There was 81 World Series. So if you triple both of these values, that would be 15 out of 81. So 15 times there was 4 games in a World Series. And then if you triple these, that's 15 again, 15 out of 81. There was 15 times there was 5 games in a World Series. If you triple these, that would be 18 out of 81. So 18 times there was 6 games in a World Series. And then you can see what happened most often. If you triple these, you get 33 out of 81. So 33 times there was 7 games in a World Series. So what we're looking for here is it's called a weighted average. Okay? So we want to get an expected value, but you can see that 7 games was occurring most often, right? The probability, again, this is the probability that goes with it. That happened 33 out of 81 times. If you reduce it, you get 11 out of 27. So all we have to do on this is I'll just write it to the side here, is all we're going to do, they actually did it for you here, but all you got to do is multiply these together. So multiply these together and then add those together, and that gives you the expected value. So I'll kind of go off on the side here and do it for you guys. So we have, let's see. So we had 4 games, and the probability that went with that was 5 out of 27. So we multiply those. Plus, then we had 5 games, and the probability that was going to occur was 5 out of 27. Again. Plus, and then we had 6 games, and the probability that went with that was 6 out of 27. And then we had 7 games, and the probability that went with that was 11 out of 27. So you just put that in your calculator, and you just multiply and add. In fact, you can type it in just like I wrote it right there. So just do 4 times 5 divided by 27 plus 5 times 5 divided by 27 plus 6 times 6 divided by 27 plus 7 times 11 divided by 27. Hit enter, and then round it off. And I got to take a phone call. Mr. Z? What's up? I got you. Okay. All right, bye. Hey, Sean, you got to go. Okay, so anyways, if you put that in your calculator and round off, you should get approximately 5.85. So that's kind of the average number of games in a World Series. But again, it's kind of weighted because like we looked up there and we saw that the 7-game series occurred more often, right? So that's your expected, your expected number of games. Again, so that kind of problem right there, that's called an expected value problem. But again, it's just a weighted average. Okay, let me see what else we got to do here. So we got to do one more example, and then I've got to show you how to do some of this stuff on the calculator, all right? Because we can shortcut a lot of this on the graphing calculator. But let me take you through this one. So we're going to look at example 4 on page 831. So let me switch the page here. So we're going to look at this one right here. And this one says that we got to find the mean, which is the average. You guys know how to do that already. And you also got to find the standard deviation. So the mean is the average. The standard deviation, that's a measure of like how spread out your data is. So if you get a small standard deviation, it means your data is pretty close to your mean. But if you get a large standard deviation, it means your data is more spread out further away from your average or your mean. Let's talk about how we do this thing. So the first thing you got to do is, I'm going to write all these values down, okay? So I guess we can kind of cheat on this a little bit right here and say, well, look, they already did this for us. So we have 1, 2, 3, 4, 5, hold on. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 data values. We don't really need to put them in order, but you can see they already found the average right here, right? They found the mean. So they added up the 10 data values. It turns out they add up to 100. And then you divide by the number of data values. So 100 divided by 10 gives you 10. So we'll kind of let them do that part for us just to save us a little bit of time. But now let me come over to the side and make this chart and explain to you what the heck it means. So let's make sure I can see this in my book. All right, so over here, we're going to try to make this chart. So here's what we got. Let me try this. So I'm just going to write the data values again. So they were 14, 13, 16, 9, 3, 7, 11, 12, 11, and 4. So that's all the data values. And then I'm going to make a little chart like this. Actually, let me do this. Get a little bit wider. One more there, and then this thing's going to go like this. Okay, so this top row, that's just X. That's our data value, okay? And then what we want to do in the next row is we want to take the data value X minus the mean. So this next row is going to be X minus the mean. And remember that on the previous page I showed you there, for this one, the mean, the average was 10, right? So for example, for this first, let me do this first. For this first box right here, we're going to do the data value, which is 14, minus the mean, which was 10. Okay, so 14 minus 10, that's 4. Then we're going to go 13 minus 10, that's 3. Then we're going to go 16 minus 10, that's 6. 9 minus 10 is negative 1. 3 minus 10 is negative 7. 7 minus 10 is negative 3. 11 minus 10 is 1. 12 minus 10 is 2. 11 minus 10 is 1. And 4 minus 10 is negative 6. Okay? Then we're going to square all those values. So this next line in this chart, this is going to be the data value minus the mean, whatever that number is, squared. So for this first one here, we got to take 4 and square it. Well, 4 squared, that's just 4 times 4, right? So 4 squared is 16. 3 squared is 9, 6 squared is 36. Now, when you get to the negative values, well, negative 1 squared, that's negative 1 times negative 1. That's positive 1. When you go to do this one right here, negative 7 squared, well, again, that's negative 7 times negative 7, so that's a positive 49. So negative 7 squared is 49. Negative 3 squared is 9. 1 squared is 1. 2 squared is 4. 1 squared is 1. Negative 6 squared is 36. There you go. Now, I know this is kind of a pain, but I'm going to show you a shortcut on the calculator here in a minute. So the next thing we got to do is we got to get a thing called the variance. So to find the variance, what we're going to do is we are going to average all of these numbers. Right there. So let me go ahead and do that while I'm on this page here. So for the variance, the symbol for the variance is the Greek letter sigma squared. And so we're going to square all these things. I'm not square them, I mean we're going to average them. So this thing is called the variance. And so we're going to average all these. So we're going to do 16 plus 9 plus 36 plus 1 plus 49 plus 9 plus 1 plus 4 plus 1 plus 36. And we're going to do that whole thing divided by 10 because we got 10 values there. Let me make sure I got all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our variance then, that is going to equal, I don't know, what does that come out to be? I think that comes out to be 162 over 10. So that's 162 over 10, which will give us a variance of 16.2. And then to finally get from the variance to the standard deviation, you just take the square root of that number. So the standard deviation is what we actually wanted for this one. So let me write that down. So standard deviation I didn't write standard, I wrote stand. Hold on. So standard deviation. So the standard deviation, all you got to do is take the square root of the variance. And the symbol for that is just going to be this sigma. So it's going to be the square root of 16.2. So if you do that on your calculator, you should get like 4.02. All right, now the rest of this lesson, I'm going to have to go to the graphing calculator for you guys. But that is how you find the mean and the standard variation. A quick discussion of what the standard deviation is. Again, it's a measure of how spread out your data is. So for example, when I give a test in this class, pretend that these scores up here at the top, pretend those were like quiz scores. All right, well, the average was 10, right? We got that up here, if I move this a little bit. So the average is 10. And if I move one standard deviation above 10 and one standard deviation below 10. So that would be like 10 plus 4.02 and 10 minus 4.02. So that would be what, like between 14 and 6? 2/3 of my data will fall, if it's normally distributed data, like when I give a test in here, 2/3 of you guys would fall between 14 and 6, 2/3 of your scores. That's one standard deviation above 10, the average, and one standard deviation below the average of 10. And then if I go out 2 standard deviations, so if I go 10 plus 2 times 4.02, that would take me up to like 18. And then if I did 10 minus 2 times the standard deviation, that would be like, 2, right? So that means that then about 95% of your scores would fall between 18 and 2, or between 2 and 18. So that's kind of what the standard deviation is. It's a measure of the spread of the data. So if the standard deviation is small, the data is packed very closely around the mean. But if the standard deviation is large, then the data is more spread out from the average. And like I said, I think I'm going to have to leave it there, and I'm going to have to switch to the graphing calculator. So remember those values. Hopefully you wrote them down, because I'm going to go back and confirm them with you guys. And then I guess the people that are quarantined at home, they are going to have to see me when they get back in terms of how do you shortcut this stuff on the calculator. And they should also take a detailed look and read example 5 on page 831, because that's the next example we're going to do. But let me stop this recording.